My name is Sarah Chang. I am a PhD candidate in the Department of Biomedical Engineering at Case Western Reserve University. I'm also part of the Advanced Platform Technology Center here at the Veale Medical Center. I'm currently being funded by an NIH musculoskeletal training grant as a part of the Department of Orthopedics at Case Western. My research is currently funded by the VA and the Department of Defense. It's a project called the Hybrid Neuroprosthesis. This combines two technologies, functional neuromuscular stimulation and lower extremity bracing. We work with individuals who have paraplegia due to spinal cord injury. We take a muscle-first approach, which means that we use the functional neuromuscular stimulation to contract their paralyzed muscles, and this generates the joint movements that we need to enable them to walk or stand up. And we use the lower limb or lower extremity bracing in order to stabilize them during those different movements. The system, the hybrid here, uses an onboard controller, and if I use this wireless finger switch, I can control what state the finite state machine goes into for our controller. So if I press the green button, I can now stand up because all of the joints become unlocked. And I can lock the brace. So we have it set up such that it's manual stepping, so I am the one that indicates it goes to the next step. One aspect that's next is hip power assist. We find that sometimes they have inconsistent joint trajectories, and we want to enable consistent trajectories such as during stair climbing. So by adding in this power assist, we'd be able to do that. There's a couple of challenges that we're facing, one of which is the fact that we're using off-the-shelf components. This limits our ability to make the device smaller as well as lighter. If we were able to incorporate more advanced technologies such as using carbon fiber, that could reduce the weight of our device, and maybe creating specialized components could also reduce the weight. The aspect from the user that we're having difficulty with is getting sufficient foot floor clearance, which means that they tend to drag their toe on the ground, and this can lead to trips or falls. So we're trying to improve that as well.